Hi everyone, and welcome to this demo of AICert, a secure bill of materials system designed to address the lack of traceability in AI. So let's get into it. What is AICert? AICert is a technical framework designed to address some of the most urgent concerns relating to AI provenance. It's going to allow builders to create these unforgeable model cards that cryptographically attest to their model's property. This way, the AI provider can provide this strong audit trail with irrefutable proof, which is going to be key for compliance, transparency, and security. They can prove that their AI model wasn't trained on, say, copyrighted or biased data or personal data without consent. And they can provide an AI bill of material about the data and the code used to build their model, which is going to make it much harder to poison the model by injecting backdoors in the weights. The concept of AICert is to make AI traceable and transparent, by allowing the AI builders to create these certificates, these cards containing cryptographic proofs binding the weights of the models to a specific training data and code. And then the final consumers of the AI model, so the end users, they can then verify these AI certificates and be sure that the model that they're using comes from a specific training set and code, and guarantee that they won't face copyright, security, or safety issues. Let's now talk about how this works. So AICert will take the model training inputs, which might be defined in an Axolotl configuration file, for example, and it will transform them into a model card that will bind the model's output weights to specific properties, such as the code used, amount of compute, or training data. These are bound cryptographically and they're non-forgeable. So instead of AI model builders just declaring a model was trained in a certain way, now they can actually prove it. And if we actually have access to the training data, so instead of AI model builders just declaring a model was trained in a certain way, now they can actually prove it. And if we actually have access to the training data itself, we can generate the same cryptographic hashes and verify that it is indeed the same as the one on the model card. So our POC is currently limited to fine-tuning, but might be extended to the full training process at a later date. AICert is based on trusted platform modules, or TPMs, and these are cryptographic modules that ensure the integrity of the entire software supply chain. Firstly, technical measurements will ensure that the system components have not been tampered with or altered, and then TPMs will bind the inputs and outputs of the fine-tuning process, providing cryptographic proof of model provenance. This way, the end users can verify the full software stack used during training, ensuring transparency and trustworthiness in AI model deployment. Building on this foundation, we can imagine a framework where regulators could verify the compliance of AI models used within their jurisdictions, ensuring that the models adhere to local regulations and do not expose users to security risks. Just before we get into the demo, just a note about how you can get started with AICert. You can download the project from our GitHub repo and then follow the Get Started guide in our docs, which is going to walk you through an example. Feel free to reach out to us if you have any issues or you want any more information. And note that the project is open source under an Apache 2.0 license, so anyone can use it and build on top of it. But let's get to the demo now. So in the beginning of this demo, we're basically switching to a directory that contains the configuration, as you can see here. So the AICert.YAML, which is the fine-tuning configuration, it defines how many epochs the training is going to use, and it's going to define all of the other relevant parameters. Once we're in the right directory, we use the AICert fine-tune command, which will deploy a VM based on our MiFROS AICert image, which is an isolated enclave image that already has the fine-tuning framework within it. As you see, it says it's deploying the VM and initializing the server. This usually takes a few minutes, but we've sped that up for the purposes of this video, and it will just keep waiting until the VM is up and responding to a request. Once the server is up, it responds with an attestation document for the state of the machine. So we verify to make sure that all the measurements are correct and we're running the right image with the right fine-tuning server. And if that's correct, we can then send the fine-tuning configuration to the server. So this is going to include the data set to use, which model to use, how long to train for, all of these kind of details. Once the server receives the configuration, it's going to download the model and the dataset and anything else that's required and start doing the fine-tuning. The outputs of the actual fine-tuning are logged on your screen as well, so it's streamed and you can see on your screen in the moment what's going on. This will take a little while because this is the process where the actual fine-tuning is happening. In this case, it's a very short training session. That's just for the purposes of the demo. It's done with just one epoch. A real fine-tuning session would take much, much longer. Once the fine-tuning is complete, the server responds with a new attestation document, the AI Bill of Materials. This is a document that contains a hash of everything that was used in the fine-tuning, what framework was used, what config was used, which dataset was used, how long did everything take. Basically, everything the config specified is verified to have happened. The AI Bill of Materials is sent over to the client and verified on the client side, and that is done by using an Azure certificate chain to make sure that this came from a valid VM that is on Azure, running the expected server and image, and so on. Once everything is verified, you also get a link printed on your screen, which is where the fine-tuning model has been stored. So you can use that link to access the model that's been fine-tuned. And finally, the client is then going to destroy the whole VM and server that was used for the fine-tuning, so nothing remains except for the model with the output of the fine-tuning. You will also have the available materials on the client side. Just a final note to tell you a bit more about us before we end this video. We're Mithril Security, the AI safety startup behind the project. We're a cybersecurity company specializing in AI traceability and confidentiality solutions, leveraging hardware with enclave-based solutions to build trustworthy AI. To build this open source project, we teamed up with the Future of Life Institute, a leading NGO advocating for AI system safety. Thanks for listening, and see you again soon.